Hi everyone. So we still have about 40 minutes before the session starts. So please feel free to ask questions. A question is, in the labs, we always get a password of a domain user, but what is the best attack path if you break into a system and only have a local user account? What is the best way to move laterally? A suggestion in the question is, or a comment in the question is, escalating privileges and running mimickers to get domain user hash and then use it. Is that a path? So of course, if assuming that the local user access that you have is not an admin access, I would always recommend to go for it. That is, go for at least the local admin privileges. However, if you have to choose, let's say, if you have to pick between whether to go for a local privilege escalation first or compromising a domain user, I would always say go for a domain user. Having said that, moving from a local user to domain user may be not easy without having local admin access. I mean, you would not be able to do a lot of enumeration. You would not be able to, let's say, use popular privilege escalation techniques like Kerberoasting, etc. So as Micah, you suggested, I would say go for local admin privileges. Why? Assuming that you have local user access on a domain joined machine, if you can escalate your privileges locally, you can extract the credentials of the machine account and can use that at least for some enumeration at the domain level. So that would be a good starting point to at least get some situational awareness about the domain. So in a gist, yes, escalate your privileges locally and see if you can get a domain user, or better, start as soon as you have local admin privileges, get the machine account credentials, machine account hashes, and use them to get some information about the domain. So that would be a good way to start it. Any other question? Another question is, or a comment is, on the same question, a question is, I don't know whether I have to have a domain joined user to retrieve WMI using WMI locally stored information about AD with things such as, and then there is a WMIC command. Yes, I am root. You would need domain user for that. Any other question? So I need to keep talking so that the when you see the recording later on, there is no silence in between and you can watch it relaxed, right? There should be no need to skip stuff. Any other questions, please? The question is, should we already be able to access the VPN? Yes, you should be. If you are facing any problem with that, check out the announcement section. There is an email for the lab team there. You can reach out to them. However, please keep in mind that I do not expect you or recommend to do the hands-on with me during the session. You would not be simply able to keep up because I've not designed the course that way. What I expect from you is to pay full attention to the discussions and the questions that your fellow students have. And then after the session, you can practice in the lab. So even if you could not, for some reason, access the lab environment right away, it is absolutely fine. Think of this as a lecture, and then you practice afterwards. Another question is, if you only find the KRB TGT or the Kirby TGT account as Kerberos table, can you use this for an attack? Rarely, my CA, absolutely rarely, like once in a million opportunity. Rarely would you be able to brute force the password, the hash of the Kirby TGT account, because that is set by the machine. I mean, even if you set a password for the Kirby TGT account, that one is not used. It is always machine generated. Any other questions? So because there are no more questions, and I think we have enough, there are many of us on the Zoom call already. So what are the cities that we have in the class, or the countries? If you do not want to reveal your city, then what are the countries that we have, or the time zones? So please keep all the communication on the Discord channel. We have Ajit. Sorry, let me not see the names. I'll see that later on. We have students from UAE. That's great. We've got someone from Netherlands, Virginia, US, Munich, India, Texas, US. I'm sitting in India as well. So because there are no more questions, you are forcing me to talk weather now. And the summer has started hitting us badly. So we are already looking at 40 degrees Celsius. And my city is one of the better ones, I mean the cooler ones. All right, you see my background? That's the lake in my city. It's a huge one. So my city is used to be pretty used to have pretty normal climate, rather pleasant one. But now it's raining fire. And I believe, as usual, we have a very good mix of red and blue in the class. 12 degrees Celsius. Okay, I would, right now, I would kill to exchange that with feather of my city. So what do we have? I believe a healthy mix of red and blue in the class. The question is, can you confirm what all the materials are shared in email? You would have the Discord link, the Zoom link, and access to the learning material that includes slides, lab manual, tools, and a guide to how to connect to the lab. So you've got, most of you are, I mean, 3 of you are from red team. So I usually always ask this: if I have more red teamers in a class, then I bitch about blue teams. If there are more from the blue side, then I bitch about red teams. But that's not the case. I mean, usually it is almost an equal, a bit of tilt towards red team when it comes to number of participants. Or probably because this is the advanced one. So we would have more red teams. Okay, we got one from the blue. For sure. I hope that the first session is good enough to help you in tomorrow's assessment. I mean, we would mostly be doing only discussing on the enumeration today, and some signature-based bypasses, etc. But I hope that is useful. You won't get the tools or manual on email. You have to access the lab portal. Check out the announcements channel. You have to access the lab portal, and there you would get everything. All right, any other question, or I'll start the session now. Because there are no more questions, let's start the session. Hi, everyone. Welcome to Active Directory attacks for red and blue teams. Advanced edition. I'm an instructor, Nikhil Mittal. So before we start the session, some things about me. You can find me on Twitter. I'm Nikhil_MITT on Twitter. I'm the author of Red Team Labs on Pentester Academy. I used to blog a lot on labofopenetration.com, not anymore, but it's still a good place to check out some Active Directory and PowerShell research. I've created tools that are useful for both red and blue teams. Tools like Nishang, Deploy Deception, Race Toolkit, etc. You can find them on GitHub. I am Samrat Ashok on GitHub. I'm interested in offensive information security, new attack vectors, methodologies to compromise. Of course, we have the permission to do so, to compromise on-prem Active Directory, Azure. I'm also interested in partial security. I've previously spoken multiple times at DEF CON main stage, DEF CON villages, different versions of Black Hat. I've spoken there, I've trained there. I'm training this year as well there. I regularly speak and train at BruCon. I first spoke at Black Hat, I believe, in 2010 or 11. There used to be a Black Hat at Abu Dhabi. So that was my first placket. I think it was 2011, a fantastic place. Not as chic as Dubai, but still a great place to have. And Brugor, of course, I know that there are some Belgians here in the class. Ghent is a fantastic place. I could not wait to visit it soon again. So what are we going to cover in the class? As you might already know, there are 4 sessions in the class spread across 4 weeks. So what we would cover in the very first week, that is today's session, is we'll start slowly with, not slowly, we'll start with an introduction to Active Directory. We'll take a quick look at attack methodology and some tradecraft. Then we'll move on to domain enumeration. And there we'll spend a lot of time today. We'll see how, as a normal domain user, we can gather a very interesting set of information from the domain controller and other machines, other member machines. We'll see how we can chart attack paths using that, how we can find out users, groups, different ACLs, overly permissive ACLs, stuffs with group policy, trust relationships, and whatnot. And then if time permits, we'll start looking at local privilege escalation opportunities. That is not local privilege escalation opportunities, both on your foothold and also by using or abusing the trust relationship and permissions that you have on OUs, on other machines in the network, abusing stuff like labs, etc. That is what we'll do if the time permits at the very end of the session. And that would also include credential replay attacks, like, for example, passing a ticket PTT, overpass the hash OPTH, etc. That is what we'll cover today. Week 2, 3, and 4, then that you can take a look at later on. Now, the goal of this class, I do not expect expertise with Active Directory security. However, because this is an advanced edition, I expect some knowledge of Active Directory security and familiarity with Windows command line. That is, you must be able to run tools. Pretty copy-paste stuff when it comes to running tools, but still, you should be able to run them. I do not expect any red team or penetration testing experience. However, if you have that, then it would be helpful. Both Hunterbot. If you have experience with Windows command line, that would work as well. So the way the course is designed, I will introduce a concept. Let's say overpass the hash. Then or ACL. Let's talk about a feature. Let's say I'll introduce a concept ACL. I'll then demonstrate how an attack can be executed, how overly permissive ACLs can be abused. And then there is a learning objective or hands-on section where you can practice in the lab. As I said earlier, please keep in mind, I do not expect you to do the hands-on with me during the class. Please absolutely do not try that. You would not be able to keep up with me. You're supposed to do the hands-on later on. I mean, after the session, not during the session. All right. Now, like a real-world operation, the lab forces you to use built-in tools as long as possible and focus on functionality abuse. So in this course, we will absolutely not use any exploits or exploitation framework. I mean, there are no CVEs or patchable vulnerabilities that we are going to use or abuse. We use an assume breach scenario in the lab. We start from a foothold box as a normal domain user. And please keep in mind that everything is not in the slides. So please stay awake, smell coffee, and probably take notes. I mean, I've tried to have multiple layers of learning aids, but still it will help if you have your own notes. Now, let's talk about what is in scope. All the machines in 192.168.1.0/24 to 192.168.102 1920x1080 for these two subnets, and your own student VM is in scope. These two machines in these subnets, 1.199 and 1.200, are not in scope. Other than this, everything else is not in scope. Please do not attack out of scope machines. That may result in disqualification from the class. Specifically, please do not access your fellow students' machines. Right? All of you are not in the same lab instance. Only a handful of you share a lab. We do not stuff all of you in the same lab instance. Still, even if you take a look at the lab manual, you can become domain admin right away in the beginning of the class. And if you want, you can cause slight disruption, at least for those who share the lab instance with you. So please do not do that. All right. Have fun and let others have fun as well. Another important thing is please treat the lab environment as lab network as a dangerous environment and take care of yourself. If you're using RDP, that is, if you connect to the VPN and then RDP to the student VM, as I do, please do not share drives or folders that you would not like others to have access to. Please do not copy over any such information on the student VM that you do not like others to have access to. Once again, all of you would have domain admin access, and it is pretty easy for anyone to access your student VM. If you're absolutely paranoid about connecting your, let's say you're using a work machine and you're paranoid about connecting it to an external VPN, you can use the web-based access. The web-based access uses Guacamole. So there is no way back from your student VM to your host machine. All right. So with that, let's move ahead. So what is the philosophy of the course? We will emulate an adversary that has a foothold machine in the target environment. Once again, we are not going to use any exploit in the class, but we will depend, or the class depends on abuse of functionality and features that are rarely patched. And that is significant. So the lab uses server 2019 machines with the patch cycle of, I believe, October or November 2021. So just a few months back. So any technique that you see in this class is absolutely going to work for at least a decade down the line, at least for 10 years. The tools may change, the detection signatures for tools may change, some behavior-based detection may change, but that's it. That is where the expiry of anything that you learn in this class happens. The techniques are absolutely going to stay here, specifically because those of you who are interested in on-prem security would have noticed this. Microsoft has stopped innovating in on-prem Active Directory security for a few years now. Their entire focus is now on moving their on-prem clients to Azure. A very good example of that is there has been no forest functional level after 2016. The latest forest functional level is server 2016, that's it. There has absolutely been no forest functional level or any changes when it comes to the domain level security or Active Directory level security. All right, so please keep that in mind. Having said that, please do not think that you would rather be sitting in the Azure Security Bootcamp that I did yesterday, actually. So don't think that you should rather be sitting in that one. No, absolutely not. How I see that, how I look at this is, there is absolutely going to be an explosion in requirement of security professionals who understand on-prem security, because Microsoft has almost abandoned it. And now when they have abandoned that, we would need, or the industry would need, more on-prem security professionals to secure Active Directory. And I'm not just making that up. The explosion of Active Directory security-based organizations recently, or companies that focus on on-prem Active Directory or on-prem AD security, that confirms this. However, coming back to this, let's begin. Let's take a look at a very quick introduction to Active Directory. So as the name suggests, Active Directory is directory service used to manage Windows networks. This stores information about objects on the network and makes it easily available to users and admins. Quoting Microsoft's documentation, Active Directory Domain Services, or ADDS, enables centralized, secure management of an entire network, which might span a building, a city, or multiple locations throughout the world. So this is what Active Directory looks like. You have different types of objects. And Active Directory provides a centralized manageability, security, and interoperability between all of these different components. Everything is an object in Active Directory. A user is an object, a computer is an object, and same goes for everything else. Now, there are some basic components of Active Directory that I would like to quickly take you through. Please note that we are not going to discuss why or how LDAP and DNS, let's say, are crucial in Active Directory functionality, or what are the different roles that the DCs might have. We are not going to discuss that. So 4 components that we are going to keep abusing in the class are, one is schema. So schema defines objects and their attributes. For example, a user object may have phone number, or their office address, or their office floor or location, etc. Whereas a computer object may have IP address, OS version. So that is defined in the schema. Now, because by definition, Active Directory can span across a globe as well, there must be a query and index mechanism that provides searching and publication of objects in their property so that users can search other users and computers and so on. Now, this information is stored in a global catalog that contains information about every object in the directory, and each domain controller in a forest has the same copy of global catalog. Now, how is that same copy maintained? Because there must be changes. That is maintained using the replication service that distributes information across domain controllers. So when it comes to administration, this is how Active Directory structure looks like. There is, even if there is a single domain Active Directory environment, that is a forest. So an Active Directory may have a forest, domains, and then organizational units. These are the basic building blocks when it comes to administration of Active Directory. Now, please always keep this in mind. Whenever you hear the word Active Directory, think of it as a forest and not as a domain. A reason of that is Microsoft considers forest to be a security boundary and not a domain. What does that mean? That means that if in a forest, your domain 1 is compromised, an attacker would be able to compromise domain 2, and that would be working as intended, and there is absolutely nothing that you can use to stop that. And that also includes the forest root. That is, even if a single domain in the entire forest is compromised, the entire forest is assumed to be compromised. And unfortunately, although there are other ways, but not the recommended way. One of the ways to absolutely get trust back in your environment is to rebuild the entire forest. So whenever you hear the word Active Directory, do not think of it as a domain, think of it as a forest. That would also help you, those of you who let's say, evaluate security products for your organization. I have evaluated a lot of Active Directory security related products, and I can tell you one thing from that experience. In my opinion, in my experience, this is the structure that a lot of organizations, including Microsoft, test their AD security products. That's it. Only the root domain. And I'm not kidding you. A lot of security products simply work if you have a single forest and you run or test the product in the root domain. The moment you run it in a multi-forest environment, I mean, leave multi-forest environment, even if it is a single forest with multiple domains, the moment you run it in the non-forest root domain, it would either stop working or give you incorrect results. So please always keep that in mind. And not only security products, your backup tools, your inventory management tools, your business continuity, everything, always try it, always check it if they work in a multi-forest environment, and if you have a single forest environment, if it works from the non-forest route. And absolutely do not allow anything to run a service as a domain admin. I mean, that comes later, but while we are on the topic, I have seen so many not only security products that would require you to run services as domain admin. Absolutely do not do that. All right. All right. Once again, we are not going to use any Unix or Linux-based tools, any patchable exploits. However, there is a Covenant Lab manual included in the learning aid. So that is something that I'm not going to cover. So if you absolutely want, if you are done with the lab in using the normal lab manual, then you can connect using the VPN. Let's say use VPN to connect your Kali machine to the lab network. And then you can use Covenant to challenge the lab or any other C2 that you want. I mean, we absolutely do not limit what are the tools that you can use in the lab. What is something that you can try in the lab? Go for it, treat the lab as a playground. Break stuff. If you break stuff, just let the inform the lab team and you would be fine. So what are the tools that we are going to use? We are going to use some C, C++, C#, all of it OST, open source tools. We are going to use PowerShell like built-in commandlets, Microsoft's own modules, WinRM, PS remoting, some public scripts, some custom scripts, and then Windows native executables and scripts as well. So let's start with PowerShell first, a very quick introduction. PowerShell comes installed by default on all modern Windows OS, and it provides access to interesting things like stuff on a Windows machine, stuff in Active Directory if you have enough privileges. PowerShell is based on the .NET framework and is tightly integrated with Windows. PowerShell is not PowerShell.exe, it is the System Management Automation DLL. That is what PowerShell is. All right. So why I've mentioned this? A lot of times I've seen people thinking or recommending, in fact, to block PowerShell.exe in an enterprise environment as a security control. Please absolutely don't do that. PowerShell.exe is just a host to run System Management Automation DLL. There are so many Microsoft signed binaries that can load this DLL. For example, PowerShell ICE, install util, MS build, look up a lolbas project. Everything there, every second thing there would be able to load this DLL. This is how we can load PowerShell scripts and modules. To load a script using dot sourcing, you can use dot space and the path to the script. To load a module or script, you can also use import module. So you can use import module and path to a script or a module as well. Once a module is loaded, you can list all the commands in the module using get command -module and module. So that is all PowerShell that you need to know to run the tools in the lab. Then comes PowerShell script execution. How do you execute PowerShell scripts? So this is arguably the most popular way for attackers. This has been in use or in abuse for almost a decade now. I mean, this has been used so much that it forced Microsoft to introduce anti-malware scan interface, or AMSI, a few years back. So what are we doing here? We are creating an instance of the net.webclient.net class and then using download string method from it. This method loads the PowerShell script in memory. And then finally, we are passing it to invoke expression to run the script entirely in memory. The next one uses a COM object of Internet Explorer. This one, which works only for PowerShell version 3 onwards, is pretty similar to the first one. Invoke web request, get the script in memory, and then pass it on to invoke expression. And a couple of more. All right. This is what made PowerShell very popular with attackers, and it is still. All right. It's still very popular. However, okay, that comes in a moment. Now, how do you interact with Active Directory, let's say using PowerShell? You can use the @ctap accelerator, you can use .NET classes, you can call native executables from PowerShell, you can call WMI, you can use Microsoft's own Active Directory module. However, in 2016, Microsoft introduced Windows 5.1. That was the last Windows PowerShell version. That is the PowerShell version that still comes installed by default on all modern Windows machines. So that is called Windows PowerShell. Microsoft now calls PowerShell what used to be PowerShell Core. That is based on the .NET Core. That is a platform independent version. But on Windows machines, still it is Windows PowerShell that comes installed by default. Now, there were some enhanced logging capabilities that were introduced in Windows 5.1, or there are some enhanced security capabilities in Windows PowerShell 5.1. First and foremost, the one that scares me, system-wide transcription. So what system-wide transcription does is, regardless of what is the host that you're using to run PowerShell DLL, would let it be PowerShell.exe or PowerShell ICE or any unmanaged code. Whenever system management automation DLL is loaded, if transcription is enabled, if it is not enabled by default, if transcription is enabled, that logs everything in flat file. Right. So let's say you are pushing, if you're pushing transcription using group policy and you specify a directory, let's say C transcripts, then whenever anything loads the system management automation DLL, then the username, the host, the commands that the host, the commands that were run and their output, all of it is logged in a flat file in the directory that you specify. Absolutely everything. And this is a very, very powerful feature. However, with its own drawbacks. The biggest drawback is that it is not a secure logging. It is clear text. What does that mean? That means that for some godforsaken reason, if you're leaving your transcript files on host machines, and your administrators, of course, if they are using, let's say, PowerShell, an attacker who gets access to that machine would not only be able to see the transcript files, that is the command that they run, but also the output. So if you're using, let's say, PS sessions as we've been used, or command lines where you have to use credentials right there on the command line, then this would be a problem. All right. But for us right now, as an attacker, this is a huge drawback. I mean, so much so that Microsoft called PowerShell as honeypot a couple of times. Although I absolutely do not agree with that. That is simply trying to control the monster they've unleashed on the world. So that's why they call it honeypot or whatsoever, right? But still, a very interesting enhanced logging mechanism. Then we have script block logging. That is of two types: warning, that is 4104 in PowerShell operational logs, and verbose, that is, I believe, 4103, probably. Now, what does this do? For the warning level script block logging, there is a list of bad keywords like invoke expression, invoke web request. If you have these bad keywords in any script block, any script or any command that is run, it will be automatically logged here. This is enabled by default. There is no need to enable it. This is enabled by default on all modern Windows. If you have verbose logging enabled, then whatever you run using PowerShell would be logged. Right? That is also pretty scary. And it is easier to ship this because these are event logs. All right. You can use anything like winlog beat to forward these logs. To forward system-wide transcription, it's not as easy as using this. Then comes anti-malware scan interface, or AMSI. So what AMSI does is, let's say there is a script block that is about to run. You would have AMSI anti-malware scan interface that would get the contents regardless of the script being typed or loaded in memory or using whatever method. AMSI picks up the script content and passes it on to the registered AV. Now, if the registered AV supports AMSI, for example, Windows Defender and a lot of AVs do, it will check if there is any signature-based detection for that script block. So think of it as the wingman of an antivirus that, hey, buddy, do you have a signature-based detection for this guy? That is how AMSI works. All right. Finally, we have constraint language mode. This is something that is integrated with both AppLocker and WDAC, that used to be known as device guard. So what happens in CLM is Windows PowerShell 5.1 is smart enough to relegate to fall back to a language mode called constrained language mode, where nothing of interest works. All right, you cannot have .NET classes, you cannot run access alternate object stream like WMI and whatnot. I mean, for example, in our class, from all the things that we discussed, only Microsoft's own AD module works in CLM. Any other PowerShell tool that we run would not work. Right? So that is what the constraint language mode is. By default, a PowerShell session run in a full language mode. All right. CLM is the constraint language mode, and then there is another more restricted one, the no language mode, but that is used by the just enough administration or JEA endpoints, which is something that we are not going to discuss right now. All right. Now, these were some security controls or enhanced logging mechanisms. Something that is not a security measure or an enhanced security control is, enhanced logging is the execution policy. Please never ever think of execution policy as a security control. There are several ways to avoid it even without having admin privileges. All right. So don't use it unless you are, let's say, using this part or a variation of this to, let's say, if you have global command line logging and process creation logging in your environment, then this may sometimes may help in detection. But that's it. So don't think of it as a security measure. Now, a lot of times what I get from students and fellow red teamers is that PowerShell, offensive PowerShell is dead. I mean, Microsoft tells that it is a honeypot, so there must be some truth in that, right? With all of these detections, who would be stupid enough to use that? So I would say it is absolutely not dead. Please never ever think of or create your tool chest or your tools based on what is considered to be cool today. Right? So PowerShell, just because a lot of community champs have, let's say, moved to C#. I mean, C#, there was no move to C# before PowerShell became famous. A lot of security tooling was already in .NET. Then came PowerShell, so some tooling moved to PowerShell. Then it came back to .NET. And then even more exotic languages like, I mean, Rust. Rust is not exotic. Let's say Boolean, for example, or NIM or something like that. So please do not simply stop learning PowerShell or offensive PowerShell because your Twitter feed suggests otherwise. Those of you who, I mean, there are multiple reasons for keep learning PowerShell. One is, as we will see, there are pretty easy ways to bypass PowerShell-based detection. If you know the tool that you are running, if you know your target environment, then you can freely use PowerShell, let's say, PowerShell-based tools. You can use .NET-based tools or whatsoever. Just try to understand the tools that you are using. Also, the detections are always dependent on your target organization and absolutely on if you are using customized code. I can tell you that for EDRs worth their salt, if we talk about bypassing EDRs, that is something that I'm not going to cover, but there is always a demand for that. If we talk about bypassing EDRs like Microsoft's Defender for Endpoint, that is Microsoft's EDR, or anything good similar to that, let's say CrowdStrike or Carbon or something like that. Gone are the days where you can pick up some code from GitHub and start using it right away against any of these EDRs. You have to customize code, right? And that is true for PowerShell code or .NET code or whatever. And then there are bypasses for security controls. If the bypasses are detected, there are obfuscated bypasses. For example, you would see that the script bug logging bypass or the MG bypass that we use in the class, those are obfuscated versions of well-known bypasses. Having said all of that, please keep this in mind. The focus of the class is Active Directory and not bypassing endpoint detection and response. So how do we bypass PowerShell security? So we are going to use a minor modified version of InvisiShell, which is an open source tool. So of course, once again, if you use the stock version, that is detected by even Windows Defender. So after minor changes, it is not. So we are going to use a version with minor changes. The way this tool works is it hooks a couple of .NET assemblies. One is the PowerShell assembly, system management automation, and the other one is system.code. Now, InvisiShell uses a CLR profiler API to perform the hook. What is a CLR profiler? A CLR profiler is a DLL that consists of functions that receive messages from and send messages to the CLR by using a profiling API. That is, whenever the DLL is loaded, whenever an executable is run or a .NET assembly is called, right? At the runtime, the profiler DLL, for us that would be InvisiShell, is loaded by the CLR, and therefore the hooks are performed, which incapacitates the enhanced logging from system management automation and system.code. This is hooked to avoid script block logging. This is hooked to avoid the system-wide transcripts. All right. How do we use InvisiShell? If you have admin privileges on a machine, you can use this bat file, run with path as admin. If you do not have admin privileges, you can use run with registry non-admin. I always prefer this because this makes changes, temporary changes to HKC. This makes temporary changes to HKLM. Now, changes made to HKCU are always less susceptible to detection as compared to this. So you will notice in the lab, even when we have local admin privileges, we will use this. So when you run this, there are some registry entries that are added. Then PowerShell.exe is run. And once you exit from the new PowerShell session, there is some cleanup that is performed. Basically, the registry keys are removed. Now that was to bypass enhanced logging and other PowerShell security. CLM is still pending. We will discuss that at the time of when we encounter WDAC or device guard later on one of the machines. Now, how do we bypass signatures for PowerShell scripts? Please keep in mind that we can always load scripts in memory and avoid detection by using MZ bypass. So we run an MZ bypass and then we load a PowerShell script that may help us in bypassing at least signature-based detection. But let's say we want to bypass signature-based detection even for on-disk PowerShell scripts. We would focus only on Windows Defender in this case. So for that, we can use MZ trigger. So what MZ trigger does, it helps in identifying almost exact part of a script that is detected. For example, if you see in your C80 tools directory, you would have a script called invoke PowerShell TCP detected. So if I can simply run MZ trigger on that one to find out what is the string that may get detected by a defender. If you want to go for full battering ram sort of obfuscation, that is, you want to blindly obfuscate the whole script, see invoke obfuscation. It is a bit dated tool, but still the best thing out there to obfuscate PowerShell script. In fact, the MZ bypass and the SB logging bypass that we use in the lab are obfuscated using invoke obfuscation, and it still works absolutely fine, right? But we are not interested in the battering ram full obfuscation right now. We would like to go for minimal obfuscation. Why? I could not exactly name that, but many EDRs use what is called entropy. That is, if your code is very, very obfuscated, if it contains unusual amount of gibberish, then that actually may lead to detection. So we may always like to go only for minimal obfuscation, something that the countermeasure has a problem with, and that is something that we are going to detect with MZ trigger. So there are simple steps. We scan using MZ trigger like this, modify the detected code snippet and rescan it, and keep doing 2 and 3 unless we get MZ result not detected or blank from MZ trigger. Please do not use VirusTotal to check if your code would be detected or not if you are an offensive security engineer or a red team or penetration tester. The reason for that is, of course, you might already know that, but VirusTotal shares whatever you upload with AV vendors. So that is something that you may not like to check. A question about invoke obfuscation is, I did not really succeed often with invoke obfuscation and followed other ways. Is there one option that is especially promising with it to succeed? Yes, when you're using invoke obfuscation, always go for strings. Always obfuscate strings, because that is something that is used majorly for signature-based detection. All right. Coming back to this, let's say we scan power up using MZ trigger. So if you pick up the classic power up option, a power up version, MZ trigger complains about this line. And after some hit and trial, you will get to know that it is this system.app domain that Defender has some issue with. So what can you do in this case? Something as simple as this, simply reverse the string. All right, so what we are doing, we reverse the string and then used it in line number 59 of power up, the stock power up version that you can get, let's say, from the power spec repository. And then if you check it with MZ trigger, there would be no detection. Then let's say something called like invoke partial TCP. So invoke partial TCP is a small reversal that I wrote like what, 6-7 years ago, and it is still used. I mean, I'm not proud of it, but it is still used by even APTs. And why I'm saying that, I mean, I do not need criminals to back my argument, but because there is some sort of fascination about what are the tools that APTs use. APTs still use reverse shells that someone wrote few years back while learning PowerShell, or just for for the fun of it. I mean, look up APTs like, for example, Hafnium. Hafnium used invoke PowerShell TCP, and a lot more actually. I recall Hafnium because one of my students pointed it out in the previous run of this class. And they were pretty excited that tools as outdated, and I say that with double quote, with the air quotes, right? Outdated tools like these, like invoke partial TCP, are still being used. Please always keep in mind that no tool is ever outdated as long as the technique used by the tool is alive. All right. So coming back to this, if we scan invoke partial TCP, the stock version with MZ trigger, this is the line that Defender has a problem with. So once again, after some hit and try, you may get to know that it is net.sockets that Defender has a problem with. So reverse it or do whatever you want. I mean, just simply change the signature, and that is it. A question about invoke obfuscation: is obfuscating the AST nodes still effective? It would be. It would be. Unfortunately, if we are using full obfuscation, I mean, AST nodes allow you to, well, let me rephrase that. Yes, it is still effective, but it depends on what you test it against. To be honest, I never had the need of using AST nodes. Usually simply obfuscating strings, variables, etc. that did the job for me always. I mean, it is fascinating as a technique, but I never got to have a need of that, to be honest. All right. Does that answer your question, Alexi? Thank you. Thank you. You're welcome. I just said thank you in reply to a thank you. You're welcome. So That is how, for example, we can avoid MZ trigger, the detection for invoke partial TCP. Now let's address the elephant in the room or on the box, invoke mimicards. So invoke mimicards, those of you who are from a penetration testing or red team background would know that this is the partial port of mimicards, our beloved tool. And this is the most heavily signatured PowerShell script on this planet. I mean, probably at one time, probably even more heavily signatured than mimicards itself. So when I was trying this with MZ trigger, I had to rename it, because if I was keeping invoke mimicards as the name, I was always getting an access denied. So if you run this or pass this through MZ trigger, there are multiple things that it tells you to change. The name, of course, name of the author and their Twitter handle. Joseph, by the way, now works for Microsoft. He has been doing that for like, what, 9 years? And a lot more stuff. So first thing, and this is actually the basics of any obfuscation, always remove the comments and rename the variables. In this case, what MZ trigger suggests us is, or we can do is, first, of course, to remove the comments so that all of this is removed. Then there is a variable called, a parameter name called dumpcreds in invoke mimicards. We need to change that as well. We also need to modify the variable names of all the Win32 API calls that are detected. And the final thing, what we did is to reverse the strings that are detected and the mimicards compressed DLL string. So if you look up on your student VM, you have invoke mimicards, and I believe you would have invoke mimicards old as well. So old is the one that gets detected. And if you look at the new or the mimicards version that we are using, you can see that we can still use the function name invoke mimicards, which is absolutely fine with Defender. However, we have renamed dumpcreds to DC. We have made changes to some of the variable names. I'll show you that in a moment. And these mimicards DLLs that are embedded inside these scripts, these are compressed and reversed. And that is the reason, as you would see, if you try running this invoke mimicards, it takes about a minute before it starts running. The reason is because this whole DLL is compressed and reversed, and it is a long one. So that is what we do. We removed the comments, we modified dumpcreds, we modified the variable names of Win32 API calls that are detected, virtual protect, write, so there's a typo here, write process memory, and create remote thread. All right. And then finally reverse the strings that are detected like this, and the mimicards compressed DLL, that is also reversed. That is how we can avoid signature-based detection of PowerShell scripts, even if you drop them to the disk on a machine that has latest Windows Defender. I mean, at least the version that we have in the lab, that is, its signatures the latest. I can claim that it's the latest one because in the exam environment, we have the latest VMs. All right. So the methodology that we are going to use is assume breach that Microsoft's Cloud Red Team uses as well. So there are 6 phases in an assume breach operation or cycle: red teaming, insider attack simulation, blue teaming, executing post breach, monitor emerging threats, and war game exercises. We are going to focus the most on insider attack simulation and red teaming, and somewhat on blue teaming as well. So what is an assume breach methodology? So in place of the traditional reactive security, where reactive perimeter-based security, where you assume that you have dug trenches and you are locked and loaded for an enemy to come in. In place of that, in an assume breach, you already assume that the organization that you are responsible for is already compromised, but you have just not discovered it yet. All right, so this is the basis of the reinvention of zero trust, that marketing keyword that was once pushed in early 2010s. Then it was lost, and that gem has been rediscovered now. All right, that is, you do not trust anything, you do not trust your internal environment. Right? So in assume breach, you always assume that, okay, anyone and everyone is an adversary. There should be no trust between, let's say, users and computers and so on. And this is the kill chain that we are going to use. We will not go for the recon part. We'll skip that to save time and focus more on juicy stuff. In the recon part, in an insider attack simulation, in a assume breach, recon would be something like, let's say, port scanning, banner grabbing, etc. Or running tools like, let's say, seat belt on your foothold. That would be recon and information gathering. We'll start with domain enumeration so that more of our focus is on enterprise grade attacks or enterprise based attacks, not grade. So what would be our target? Our target is a fictional critical tech company called TechCorp. We'll target the Active Directory environment. Now, TechCorp was recently breached, and now they have segregated their Active Directory in multiple forests across departments, locations, and vendors. The target environment has almost fully patched Server 2019 machines, Server 2016 forest functional level, that is the latest one. There is nothing called Server 2019 or 2022 forest functional level. There are multiple forests and domains. However, to focus more on the AD concepts, there is minimal firewall usage that we have configured for TechCorp. Please note that on the student VMs, you can find all the tools in the C AD tools directory, and it is exempted from Windows Defender. All right. This is what the lab environment looks like. We would land here on student machines. As a normal domain user, that machine is a part of a domain called us.techcorp.local. There are multiple machines in this domain, which is, of course, a part of the techcorp.local forest. Other than that, there are 7 other forests where we have different types of trust relationships or not. And also there is very limited hybrid identity that takes us to Azure AD. So that is what we are going to target during the lab, during the course. Now, how do you access the lab environment? You need to go to the advancedbootcamp.enterprisesecurity.io. And once you log on there using the Google account, right now we allow only Google account to access the lab portal. Once you log in there, you will have access to your subscription start time and end time. This is where your lab ends. This would be your last date to attempt the CRTE exam. You can access the lab using either web access. So you can go to this URL, use the username, generate credential, and use the password to access it. Or you can use VPN. I prefer VPN. So you get the VPN config file from here, connect to the VPN first, and then you can access your student VM. All right, you can also reboot your student VM, just your student VM if you want. All right. So a question is, would it be possible to add the diagrams of the two kill chains to OneDrive? Sure, I'll do that. Now, this is how you access your lab. To access all the lab material, you click on Access Lab Material here. You would find the notes, slides. Slide notes contain this part as well. I mean, if there are any references that I've used, this note parts, that is also included in the slide notes. A documentation on how to connect to the lab manual, and lab manual takes you through how to solve the lab, and lab manual Covenant takes you through how to solve the lab using Covenant, and of course the tools that you have on the student PMs as well. All right. Then if you go to the flag verification part, there are, I believe, 60 flags. Yes, there are 60 flags to capture. If you complete all the flags, you will get a course completion certificate after all the sessions are completed. All right, there is no puzzle in the flags. You can solve them literally just by following the lab manual of the sessions. All right. Then you can also go for the frequently asked questions tab, which I wish that more of you look at, because that answers literally the frequently asked questions. And then comes the certification exam. So this is a bit blurred right now, and this is imposed on the page, so it doesn't look good right now. So the lab access comes with an attempt for CRTE, the Certified Red Team Expert certificate that we offer. You can run it based on your nearest location, and once you click on the setup exam lab, it takes 15 to 20 minutes to set up a dedicated exam lab for you. It is a complete isolated Active Directory environment. And I can tell you right away that the time it takes is more of Azure's limitation. So the lab is hosted either on Azure, rarely on AWS or EC2, or on an EC2 instance, usually on Azure. So it is their limitation that it takes time, not ours. So you get to have access to an exam lab. Exam is in 48 hours exam. If you can complete it early, it is fine. You need to compromise all the machines. There are multiple exam labs that are configured, so you may not get the same as your colleague got. All right, you need to compromise all the machines, write a report how you did it, and send it to the lab support. I personally go through absolutely all the reports. There is no one else that I delegate this task to in my team. So please make sure that you make an effort to write it. All right. So this is what the lab environment is. Let's get started with domain enumeration. There are so many tools that you can use for enumeration. The one that I like the most is, when it comes to vanilla enumeration, is the AD module. That's what, or not the AD module, the Active Directory RSET module that is signed by Microsoft. Why it even works in CLM, and there is absolutely no detection at the endpoint level when you use this one. I maintain a mirror of that tool on my GitHub. Please always keep in mind that you need to import both the DLL and the PSD1 to make it work. Then, of course, Bloodhound, that has both C# and PowerShell collectors, which is absolutely fantastic. If you want to visualize the different attack paths, it is absolutely fantastic. In addition to Bloodhound, you can also use FingerCastle. FingerCastle is free for personal usage. Therefore, I can recommend that. A fantastic tool. This is written by Vincent, one of the major contributors to Mimikatz. Then PowerView, of course. We are not going to use this version of PowerView. This needs to be updated in my bed. The version that we are going to use is a fairly recent one. So I'll update that and push it on OneDrive. But this is how you can load PowerView, or you can use import module. And finally, SharpView. I mean, there are other tools as well. These are just honorary mentions, or if we are going to use these in the class. You can also use SharpView if you are a fan of only C# tools. However, I personally do not like it because it does not support filtering on the pipeline. But you can use that as well if you want. A question about the exam is, when you click on restart exam, does it give you a new target, or does it reset to the initial state? It resets to the initial state, not even resets. I mean, it destroys your current exam instance and creates an absolute new one, including the new IP, new VPN config, and everything. That is what happens if you click restart exam after running it. A question about the exam is there a preferred reporting format? No, there is none. But I would say take a look at the lab manual. That is something that you may like to use. I mean, just explain that, okay, I'm going to use PowerView now to enumerate, for example, ACLs. Here is the command. You copy the command there and a screenshot of the output. That is what I expect. Even that is enough. However, in case of CRTE, unlike CRTP, I also require you to submit mitigations. So for example, if you find out that there is an abusable service for local privilege escalation, you must also suggest that, okay, you may, as a mitigation, that remove the overly permissive or fix the overly permissive security descriptor of that service, or things like that. I mean, that is also need to be included in the report. But no particular format or no template is present. Okay. Now let's first discuss Bloodhound. The Bloodhound is a very useful tool for penetration testers and blue teams. However, please keep this in mind, that it is a noisy tool. Bloodhound is not a silent tool. Specifically, if you use the collection method all, if you use this, Bloodhound not only goes to the DC, but each and every machine in the domain to check stuff, sessions, etc. present there. So that would result in detection just like that. So use Bloodhound if you're a blue teamer, use it if you're on a penetration test. If you are doing executing a red team operation and secrecy is paramount, you absolutely do not want to get detected, then you may not like to run Bloodhound. All right. Those of you who have never heard about Bloodhound or never used it, it is a tool that provides a very nice relationship using graphs between different AD entities, and that helps in mapping attack paths. For example, you can map a path from your current user to domain admin, and if there is one, this tool will show you that. There are built-in queries for frequently used actions, and it also supports custom cipher queries if you would like to do that. How do you collect information using Bloodhound? You can either use the PowerShell ingester or collector, or the C# one. So this generates a zip archive for you that you can then upload to the Bloodhound GUI. Please note that some tools like Microsoft Defender for Identity alerts on session enumeration on DCs. So you may like to use exclude domain controllers for that. Right. Please always keep in mind while doing the lab, I am personally, I absolutely adore Bloodhound, but in the class, I'm not using that. The simple reason for that is, one, it is noisy. More than that, I do not want you to look at magic. Bloodhound is very powerful, saves you a lot of time, but it introduces a layer of magic. For example, if you find, let's say, look for a shortest path between your current user and a domain admin, and you find one, that's more of a magic for you, even if you're using Bloodhound. Now, when you're using Bloodhound. So what I suggest and practice in the class is using tools like AD module or PowerView to enumerate step by step. Having said that, absolutely use Bloodhound even in the class. If if the lab manual contains enumeration using AD module, the solution is using AD module, always check it out using Bloodhound. That will help you in understanding Bloodhound better. And also, if in a real assessment you want to use it, that will save you some time. A question is, what is your experience with Tenable AD? I have unfortunately never used it. Another question is, from 10 to 0, what would be the scale for Bloodhound noise? The problem with Bloodhound is, go for the collection methods that exclusively talk to the DCs. Avoid session enumeration, for example, and looking for local admins using Bloodhound, at least these two, and you would be fine. Once again, if you're absolutely worried about generating some noise, it is better if you avoid it, unless you know that what exactly this tool is doing in the background. A question is, would AD Explorer snapshot be detectable in the same way as Bloodhound collection method all? I've not tested it, but I believe yes. Could be a bit less noisy MDL, because I do not recall AD Explorer checking for local admin privileges on member machines. So could be a bit less noisy, but that's it. A question is, can you use Bloodhound on the exam? Yes, absolutely. In fact, I absolutely always recommend this. Never ever try to set up Bloodhound on your exam VM. Why? On your student VM, we have already set it up for you. On your exam VM, you would need to copy over Java runtime, Neo4j graph service, then you would need to check if all the requirements are there and whatnot. So if you're attempting an exam, I would recommend you to set up Bloodhound on your local machine and just run the ingesters in the exam environment. And that holds true not only for the exam, for any assessment. There is absolutely no need to set up the Bloodhound GUI in the target environment. You simply need to exfiltrate the zip archive and you would be fine. A comment is, it seems sharphound.ps1 is deprecated. Let me check that. I'll check that. All right. So let me quickly show you Bloodhound. So first I'm going to run the ingesters. But because I'm going to use the partial ingester, let me use InvisiShell first. Let's use all for now. Now this will create a zip archive for you. Meanwhile, this runs I already have, I believe, information in my Bloodhound GUI on my student VM. So the credentials for the Neo4j graph database are Neo4j. You can find this in the lab manual as well. And pass at 123 is the credential. P uppercase pass at 123. Okay. So now you have some built-in queries. So there are there are so many interesting things, 3 that we can take a look at right away. There are some pre-built queries, for example, if you want to find all the domain admins. So there are just 2 in our current domain, or let me say that in the snapshot of the domain that the Bloodhound ingesters captured. Please always keep that in mind that this is not always live. All right, this shows you a snapshot the moment when you ran the ingesters. Let's check for shortest path to domain admins. So there seems to be no path directly right now. You can map domain trusts and whatnot. I mean, there are many interesting things that you can do. List all Kerberos table accounts. There are 3 Kerberos table accounts, etc. And we can also go for node information. For example, if I check it for my current user, I can find out some very interesting things. For example, our group memberships, enrolled group memberships. So student user 1 is a member of all of these groups. Our local admin rights and derivative local admin rights, if any. Outbound security controls, that is ACLs, where we may have some interesting permissions. Right. So for example, student user 1 is a member of student users group, that is a member of maintenance users, that is a member of managers, and that has the capability to add member to machine admins. All right. Then there are inbound control rights, that is what principals have controls on student 1. So domain administrators, account operators, domain admins, and enterprise admins, these have generic all. Administrators have generic right. And these couple of unresolved identifiers have forced in password on this user. And then we can also use pathfinding. For example, from student user 1, if I would like to, let's say, find a path to the domain admins, there is no path. From student user 1, is there a path to, let's say, machine admins, a group? There is a path. Oops. So from student user 1, as we saw earlier, is a member of student users group. That is a member of managers, that is a member of maintenance users who can add members to machine admins. And so on. I mean, always, you can always keep coming back to Bloodhound during the lab enumeration to check if any enumeration can be done easier with the help of Bloodhound. All right. Now let's start looking at enumeration using command line codes. I mean, step-by-step enumeration. So once we land on a foothold, let's load the AD module in one of the command sessions here. So I've started InvisiShell, and then let me import the DLL for the AD module, and then the module for the AD module. And in another command prompt, I will start InvisiShell and then load PowerView. Why are we starting InvisiShell? To bypass system-wide transcripts, suspicious script block logging, and AMSR. Right? Now, in these slides, you would see that there are two types of font in use. The darker one lists the commands used by that can be run using PowerView. The lighter one uses the commands from the AD module or the Active Directory module. All right. So here, if I run get AD domain, we get some information about the current domain. We are currently member of us.techcop.local that has forest functional level Windows 2016. This is the SID of the domain. It is part of course, of the forest techcop.local. It seems to have just one DC, US DC, that we'll confirm later. Yeah, that is it for this one. Here, if I run get domain, we get information about the current domain. This is using PowerView, just as an example. We can get domain SID for using this as well. Please note that there is a trust relationship between all the domains of the forest. This means that we can request information from other domains in the forest as well, including the forest root. That means that we can run this also on the forest root, techcop.local. All right. Once we have some basic information, let's move ahead. Another interesting thing to look at is the domain policies. And this is available only using PowerView. So if I run here, we have different policies here. System access lists your password policy, and Kerberos policy is also very interesting. What is this Kerberos policy? Oops. So this Kerberos policy, as the name suggests, lists the policies for Kerberos tickets. Now this comes very handy later on once you have domain admin privileges or admin privileges on a machine and you start forging TGTs and service tickets or TGS. This would be handy. Why? Max ticket age, which is, I believe, 10 hours by default, that is for a TGT. Max renewal age, once again for a TGT. Max service age, 10 hours for a TGS. Clock skew, 5 minutes. Why is this important? It always helps. As I said, we are avoiding discussion on EDRs, but when it comes to detection of our AD-based techniques, we are going to take that absolutely head-on. We're not going to avoid any such detection. We are not going to avoid any such discussion on AD-based detections. So if you create, let's say, a golden ticket using Mimicards, and yet you do not specify options for your ticket to be compliant with this, that would result in a detection. What detection? Detections like this. Suspected golden ticket usage, time anomaly. Administrator used a Kerberos. Okay. I think I broke something while explaining stuff. Okay, let me log in again to that. Just give me a second. So are you able to take a look at the error that we got there? Because this is, let me put it in a new session. Just give me a second, I have to log in there. I think I should be able to access it now. Yes. So what you will get if your golden tickets, let's say, or your silver ticket, no, not silver tickets, if your golden ticket is not compliant with this, with the Kerberos policy that your target environment uses, you would get detections like this. Administrator used a Kerberos ticket from whatever, exceeding the maximum lifetime for user ticket. All right. That was Microsoft Defender for Identity, MDI. So please always keep this in mind. Please always enumerate this. And then when you create your tickets, specify, make your tickets compliant with this policy. A question is, are we going to have MDI in the lab as well? Unfortunately, no. The reason is telemetry. I used to have ATA, the precursor of MDI, in all the advanced labs. Just till the last session. But because that is not generally supported anymore, that is a deprecated tool, I removed that. But cannot replace that with MDI. The simple reason being the telemetry that Microsoft collects for MDI. That is very verbose. But I can assure you that, I mean, whatever we discuss in the class, I have tested that against MDI. So it would be fine. Unless, I mean, of course, detections move very fast as well. Right? Almost as you're fighting Skynet with so much of AI, etc., pushed there. At least normal detections, stupid detections are very fast. Okay, so please keep these policies in mind. Now we can also list domain controllers. Let's quickly do that. If I run get AD, look, sorry, that's the AD module. If I run get AD domain controller here, there is just one DC for our current domain. That's the IP address of the DC. That's the name USDC. What else? It is a server 2019 standard machine. And this is the operating system version. So once we know some basic things, let's start looking at users. So I can use get AD user with no filtering at all to list all the users. You can go for a specific property as well. Let's say we just want to look at the SAM account name property of all the users. Those of you who are not very used to, or not very hands-on with PowerShell, if you want to remove this, then use expand property here. Now, why I like filtering on right there on the command line is you can do some minor interesting things here. For example, if you want to check the number of users, there are 76 users. You can get, of course, information about a particular user as well. Let's say student user 1. If you want to take a look at all the properties, you can specify properties asterisk, and then shows you all the properties of this user. You can also take a look at properties or attributes of users. This is very useful for situational awareness. Why? Let's take a look at this output from PowerView. So I keep jumping between tools so that you can get a taste of both of them. Let's say we take a look at the property logon count. So what do we have here? We get logon count for each and every user. All right. Okay, we'll take a break. Just let me complete the current topic. So there is a request for a break. We'll take a break after this. So why is this useful? So this is useful at least in two scenarios. One is if you want to, let's assume this scenario that you've got domain admin privileges and you would like to create a golden ticket. Always make sure that you use an active domain admin, not a stale user. Never ever use a stale user for any of your credential replay attacks. That would simply be disastrous as when it comes to avoiding detection. Why? Let's say this default domain administrator had 0 logon counts. Let's assume that. Now, if suddenly there is a logon for this domain administrator from a machine where this user has never logged in, that is definitely something that the defenders, the SOC team will take a look at. That is a recipe for disaster, if you ask me. Also, a lot of organizations, and it totally depends on what are the types of, what is the industry that you usually serve. A lot of finance companies in the finance industry, that is, those who actually have deep pockets, they use deception-based products. Now, what these deception products do, they inject decoy objects, all right? That is fake domain admins, fake interesting users that when you interact with, there would be bells and sirens. So you may also like to check logon counts and similar properties for those users. The idea is pretty simple. If you find out as soon as you get a foothold in the target environment, and if you find out that there is a Kerberos-stable domain admin or a domain admin that has the password written in description, or a process running with domain admin privileges right there on your machine, always, before going for the lowest hanging fruit, always check if that account is real or not by looking at things like this: logon count, bad password time, etc. Always take a look at that. So that would help you in avoiding detections like that. All right. And now we can break for coffee. Now we can take a break for coffee or whatsoever. All right, and we'll resume the discussion post that. So let's break for 10 minutes now. Okay, so what we were discussing before the break was we can look at the properties of users to find out stale accounts, and that helps us in potentially avoiding detection with deception tools or anything that looks at use of stale accounts, for example. Not only detection avoidance, we can also use user properties for quick wins. For example, we can a lot of times credentials for specifically for service accounts are written in the description field. So you can take a look at the description field of all the users or a particular user for strings to check if there is anything interesting. So for example, when I run this command, what I'm doing is we filter the users based on if the description field contains the string built, and then we list that. So if I run this, oops, let me copy that again. If I run this, we will get all the users whose description contains the string built. All right. So that is how we can actually look for credentials as well in the description field. Now, once we know enough about the users, let's go for computers. All right. So if I run get 80 computer filter, this one, this lists all the computer objects. So these all are the computer objects in our current domain. All right. One very interesting thing to note here is we are still looking only at computer objects. This does not mean that all of these objects actually belong to an active machine. All right. By default, any domain user can add up to 10 computers to the domain. That is, they can create up to 10 domain objects, 10 computer objects. So please always check that if a computer is active or not before trying to, let's say, attack it. If you suspect anything, any decoy computer objects. So if you look at all the properties of computer objects, you would see things like that. I believe, let me stop this. Log on count even here. So always helps to take a look at the logon count even of the computer objects. If you find out a computer object that has a logon count of 0, that means that it is either stale or probably a decoy. So worth checking all the time. Now you can filter out computers based on their operating system. You can check if you want, you can check if you can reach a computer over the network or not, and similar things. Next, let's go for groups. So if you want to list all the groups in the current domain, you can use get AD group. If you want to check, for example, the groups that contain the word admin. So if I run get AD group, we get all the groups in the current domain. If, let's say, I want to look at the groups that contain the word admin in their name, then these are the groups. You would see that some important groups like enterprise admin are not visible here. Why? Because enterprise admin is present only in the forest root. We can check memberships of groups, for example, by using get domain group member with the recurse parameter. We get all the members of the domain admins group. If there are groups, nested groups who are member of that group, we get down up to, thanks to this recurse parameter, we get up to the last member of the group. Oops, wrong command, my bad. So in our environment, there are just two domain administrators, one the default domain administrator and another one is called DAC-DA. Please keep one very important thing in mind that a lot of hardening guidelines request you or suggest to rename the default domain administrator. Please don't do that, because it can always be recognized using its well-known SIG. This 500 relative identifier would always be the same. Right. It is also possible to check the group membership the other way around. Here we check who are the members of this group. Here we can check what groups this particular user is a member of. So if I run this, we'll see that student user 1 is a member of a group called domain users, and another group called student users. And this is where sometimes Bloodhound excels. I mean, not only this case, but this is a good example for that. You would see that there is no recursive parameter, no recursive parameter for get AD principal group membership. But here, if we search for student user 1, and go for group memberships, you see that first degree group memberships is what we got using the AD module command, domain users and student users. But if we go for unrolled group memberships, this is where a group that student user 1 is a member of, if it is a member of another group, if it is a member of another group, that shows up as well. All right. Our question is, could we use the name of the account and the SID to determine if an account is a potential honeypot? For example, an account named admin without a SID of 500. Yes, absolutely. Absolutely. Look for lazy honeypots, lazy mistakes like the one you pointed out. That is, if there is a user who is named administrator, but the RID is not 500, then yes, absolutely. We can also get local group memberships on a machine. Please note that for all of these three commands, to run them, to be able to run them on anything else than the DC, you need local admin privileges. You can get all local groups on a machine. On the DC, you can run it without admin privileges, but needs administrator privileges on non-DC machines. You can get membership of all the local groups using getnet local member from PowerView. Both of these are from PowerView. For example, if I run this command, I should be able to list the members of the local group called administrators on the DC. This is a PowerView command. So what we have here is on USDC, the local administrators group, not the local administrators group, the domain local administrators group has the following members: the default domain admin, the domain admins group, and the enterprise admins group. All right. With this, we are now ready to do our hands-on one. Enumerate following for the us.techcop.local domain. users, computers, domain administrators, enterprise administrators, and Kerberos policy. We've done all of it, but let me do it quickly so that it acts as a refresher as well. Recall that we have the AD module loaded here from a PowerShell session that we ran using InvisiShell. So local enhanced logging would not impact us here. To list all the users with, let's say, just their SAM account names, we can use this. That is our first task. To list all the computers, we can use get AD computer. We want to just list their names here. To list the members of the domain admins, we can use get AD group member, and we pass the identity domain admins there. As we saw earlier, there are just 2 domain admins. To find out members of the enterprise admins group, we need to specify the server techcorp.local because the enterprise admin group resides only on the forest group. So there is just one enterprise administrator, the built-in domain, the default domain admin of the forest group. And finally, for Kerberos policy that can be read using PowerView, that is what we saw. Now that was about the first step of enumeration. Let's keep our discussion on. Let's see what can we enumerate from group policies. Those of you who have never used group policies, think of them as the de facto management tool for on-prem AD. All right, a group policy allows configuration of security settings, other registry-based policy settings, preferences like startup, shutdown, log off, log on scripts, software installation, etc. Now, because group policy is useful for administration, it would also be useful for attacks. All right, anything that is useful for administration is useful for attacking as well. So all of the commands here are only from PowerView. How do we get a list of group policy objects in the current domain? We can run get domain GPO for that. So there are, let me filter this based on display name. There are 6 policies. 2 of them are default ones that you will find in any Active Directory environment. 4 of them are administrator defined. Now, one very interesting policy that is abused a lot of times is restricted groups. So restricted groups is a group policy setting that allows you to add domain principals to local groups. Let's say if you would like to add a particular domain group to the local administrators group of a machine, of machines in an organizational unit, then you can use the restricted groups setting for that. So if I run get domain GPO local group, we get a list of those domain security principals that are member of a local group thanks to the by using the restricted users policy, the restricted groups policy. So what do we have here? In the group policy, whose display name is MGMT, and the name is this, restricted groups is in use. What is the setting? The group machine admins is added to this local group. Does anyone recognize this SID, this well-known SID? Anyone would like to answer this on Discord? That is the local administrators group. Right, so what does this setting means? This setting means that the domain group machine admins is a member of local admin, a local administrators group on all the machines where the MGMT group policy is applied. So what would be our logical step when we would like to abuse this? We would check on what organizational unit this group policy applies and what machines are a member of that group, a member of that organizational unit. All right, then we simply need to compromise or get membership of this group, and we would be local administrator on all the machines there. And this is something that we are going to abuse later on. Now, if you want to check, or if you want to get a list of users or groups who are in a local group of a machine using group policy, then we can use get domain GPO computer local group mapping. So if I run this, if I want to check if there is a security principal that is a member of local group on the student one machine, I will run this. So we got an error. There is no such object on the server. There is no such security principal. If I, for example, just to show you how it looks like when it is populated, if I run this, we'll see that we get it for US MGMT machine. That is the setting actually that we will discover later on, but I just wanted to show you how it looks like, how the success looks like for this command line. We can also check the machines where a given user is a member of a specific group. For example, if you would like to check if student user 1 is a member of any machine, is added to the local group of any machine using restricted groups, we can run that. As you would see, this is not a member. This user is not a member of any local group using restricted groups policy. So what we are doing right now is we are simply trying to understand what can be potentially abused. We are still in the enumeration phase. We are not going to abuse any misconfiguration that we encounter right now. We are simply gathering information on what can be done. Now, similar to get domain GPO, if we run get domain OU, that lists all the organizational units in the current domain. These are the OUs. There are 4 organizational units: MGMT, male MGMT, PAW, and students in the target domain. So a tiny environment, to be honest. Now, if we want to get group policy applied on a particular OU, we need to read the GPO name from GP-link attribute. All right. So if we want to check, let's say, what group policy applies on the students OU. So in the GP-link, we will have the name of the group policy, and then that is something that we can use with get domain GPO. So on the students OU, student policies is the group policy that is applied. However, there is no way for us to find out the exact settings. I mean, we can find it out for the current machine using GP results or rsop.msc, but not on a remote machine. All right, any questions on whatever we have discussed up to now? Finally, if you would like to take a look at or enumerate users which are in a local group, users or security principals, not only users, If you want to list security principles which are in a local group of a machine in any OU, using group policy, we can run the very first command. So what are we doing here? We list all the organizational units, and then for each, percentage stands for each object. Now for each object written from the left side, we list all the domain computers, and then on each computer, we run get domain GPU computer local group mapping. So if I run this is a very rough command. You will get a lot of errors. I mean, it doesn't catch the errors. But if I run this, we'll see that, let me stop it. We'll see that what we got is that on the US MGMT machine, the machine admins group is added to a local group thanks to the restricted groups policy. Once again, if I go through the command, we listed all the OUs, then for each one of them, we listed the computer inside the OU. And then on each computer, we checked if there is a restricted groups setting. All right. We can do that for a specific OU as well. That is, let's say in place of all the OUs, we can specify an OU identity. All right, and this seems to be a bug in PowerView. Otherwise, simply passing the OU identity should work. All right. Now this brings us to our hands-on tool. Enumerate following for the us.techcorp.local domain. Restricted groups from GPO, membership of the restricted groups, list all the OUs, list all the computers in the student OUs, list GPUs, and finally enumerate GPU applied on the students. So let's do that. The first one was to list restricted groups. We've already done that. Get domain GPU local group. All right. Membership of the restricted group. Let's see if machine admins has any members. No members for machine admins. The next one is to list all the OUs. We can use get domain OU for that. Now the next one asks us to list all the computers in the student's OU. For that, we can run this command. Let me run the command first, and then I'll explain how it works. So these are the computer objects in the student's OU. So what are we doing here? We request an object of the student's OU. Then from whatever is written on the left side for each one, we run get domain computer, but in place of searching at the domain level, we limit the search at the current object. What is the current object? The student's OU. And that is how we get the list of computers in the student's OU. Next, to find out the group policy that is applied on the student's OU, we need to get the GP link property from this command. That is the group policy that is applied on the student's OU. That is something we now can use with get domain GPU. So it is the student policies that is applied on the student's OU. So our question is, can you please explain search base? So when you run get domain computer without a search base, the search base is at the domain level. That is, it searches for computers at the domain level. Now, when we specify a search base, it is limited to a particular OU. What this $_ is, this is the current object passed from the left side of the pipeline. So when we run this, the current object is this. This $_, when we use it in the pipeline, this $_ simply means the distinguished name of the student OU. So if we use get domain computer search base, And if I specify just this, we will get the same result. All right. So this command was simply a way to programmatically run the same thing. But we simply dynamically got the distinguished name of the student's name. All right. Now, continuing our discussion on enumeration, let's talk about ACLs. Sorry. So ACLs are central to the access control model in Active Directory. So whenever an object wants to access, whenever a process wants to access an object, there are certain pieces of information that a process would have and the object would have. What the process has is an access token. That is the security context of a process that contains identity and privileges of the user in whose context the process is running. And then there would be a security descriptor that contains SID or SID of the owner and two lists that control access and logging on that object. Think of it as your access card in your, let's say, in your office premises. Your access card contains your identity and your privileges. That is, for example, you can access the cafeteria, or you can access your own cubicle, you can access your own office floor. But you may not be able to access, let's say, the office of the CEO or something like that. So that contains your identity and privileges. And I'm toning it down. I mean, it's not as lame as I'm explaining it, but I've chosen a very simple example here. So that is what access token is. Now, when you present that key card or your ID card to a reader, let's say you want to access a cafeteria, when you present that access token, now that card reader would have a list of who can access the cafeteria. All right. So for example, it would have a list of users, a list of identities who can access it. That is what the target object would have. For example, now let's take an example of Active Directory, not of a cafeteria. Let's say a process or thread has an access token. What would the access token have? The user's SID, group SID, so the user is a member of, any other privilege or access information. Now, when this process or thread, let's say, tries to access this object, the object would have a security descriptor that would have the owner's SID, group SID, a SACL that controls logging, system access control, and a DACL, or discretionary access control, that contains a list of, literally a list of who can access the object and what they can do with it. So the checking is per entry. Can you access or not? Can you access or not? Can you access or not? And so on. If the check keeps on, is going, each ace is checked until the access is granted or denied, or there are no more aces. All right. So what are these ACLs? These lists where the comparison was made. These lists are made up of access control entries or ACEs. A particular ACE corresponds to an individual permission or audit access. That is, who has the permission and what can they do with that permission. So there are two types of ACLs, DACL or discretionary access control. These defines the permissions that trustees, that is principals, would have on an object, and SSCL logs or audits success or failure on when an object is accessed. And ACLs are, of course, vital to the security of domain. So let's take a look at another example. Let's say there are two threads, thread A and B. Thread A contains access token of a user called Andrew and 3 groups. Thread B contains access token of a user called Jane and group A. Thread A tries to access the object. So the comparison with Deckel starts. The first entry has an explicit access denied for Andrew. Deny takes precedence. So no more comparison would be done and the thread A would get an access denied. Thread B, comparison will start. Case 1 is for Andrew. There is no identity for Andrew here. So there would be no match. Next, there is an access allowed for group A. So thread B would get access now. All right. Let me show you these ACLs on the DC. So let me just log on to the DC. So here, let's take a look at the ACL of the domain admins group. If you go to the security tab and advanced here, you see that this list under the permissions tab, this is where the DACL is. And there is an ACE that corresponds to a particular security principle. For example, you can see that this ACL for the system principle, that has full control of a lot of permissions for the exchange users. Exchange trusted subsystem has full control. That is an old Exchange version though, so please do not, I mean, this is controlled in the newer versions. This Azure AD Connect sync account that has read write all properties and so on. So the idea here is that each ACE is for a particular object. This dictates what a principal can do on this object on domain admins group. The SSCL is listed under the auditing tab. All right. Now, ACLs are one of the primary reasons, other than, of course, user rights, that makes domain admins all powerful. Why? For example, let's see ACL for any normal user. You would see that domain admins has full control. You see the ACL of, let's say, the built-in administrators on the DC. Domain admins has almost full control. On the domain object itself, Once again, almost full control over the domain admin system. So that ACL is the reason why, because ACLs control access to objects in a domain, having the ability to understand them and temper them provides us great opportunities for privilege escalation, persistence, and whatnot. Now, how do we read ACLs from the command line? We can use PowerView for that, PowerView or the AD module or Bloodhound for that. So this command lists all the ACLs for the student user one. This one lists all the ACLs for the domain admins group. We can also use ACL with the Active Directory module, but resolve GUID would not work. What is this resolve GUIDs? There are globally unique identifiers or GUIDs for users and rights and security identifiers. So resolve GUIDs resolves them to human readable format. We can, that is one. Let me show you an example of that actually. So if I run this command, that is list all the ACLs of the domain admins group. See that the last one? How can we read the ACL or how can we read a particular ACE on the command line? On the object DN, domain admins, the security identifier S1518, that is system, has Active Directory rights generic all, that is full control. This is how we read ACEs on the command line. On this object DN, this security identifier S1518 has the Active Directory rights generic all. All right. Now, a question always comes up that there would be thousands of ACLs on in a single domain. How can we identify the more interesting ones? For that, you can use find interesting domain ACL. Now, what find interesting domain ACL does is it lists all the ACLs where any security identifier has modify, generic all, or write permissions. That is anything other than read. That is considered interesting by this command. Right, so if I run this now, and okay, that was fast, faster than I expected. You see that there are a lot of ACEs here. The reason for that is we used to have an Exchange server, on-prem Exchange server in the lab. It was an Exchange server 2019 without any cumulative update. And that literally destroys your ACLs, adds so many permissions. But I've removed that now. So as you could see, these ACEs are interesting as per this tool. Why? Because on the student's OU, the Exchange Windows permissions group has delete, tree, and write tackle, the ability to write permissions. All right, the question is, how can you abuse the ACL misconfigurations identified during enumeration? We'll come to that. Right now, we are in the enumeration phase. All right, this brings us to hands-on 3. Any question on whatever we discussed on ACLs? One thing I forgot. And I always like to ask this question whenever we are discussing on-prem security. So let's assume that you have the domain admin privileges in the target environment. And if I go ahead and do something like this, that is, I provide, let's say, full control of the group to a user that I control. I would still not be a member of the domain admins group, but I would be able to control the group. So do you think that this is a viable persistence mechanism? If I provide full control on the domain admins group to a user that I control, is this sustainable? Is this would this persist? No. Why? What would be the reason? Why would it not persist? Admin SD holder. So that is something that we'll take a look at later on, but there is a certain set of protected groups that are considered to be high privilege. Domain admins is of course part of that group. There is an automatic process called SD propagation, security descriptor propagation, that runs every hour by default, that overrides any changes done to these groups. But for now, you can think of that, okay, even this may be possible to understand how powerful ACLs can be. All right. Now, this brings us to hands-on 3, which has just a couple of easy tasks. We need to enumerate ACL for the domain admins group that we did using this command. All right. Simply so that you at least try it once. Second one is the all modify rights or permissions for the student user rights. And this is once again, I mean, if we want to check permissions, interesting permissions for the student users group, for the student users, I don't believe for the group, student user X. We have to, when we run this, note that we see a property called identity reference name. So we can actually filter that for the property. That is when the identity reference, name equals student user 1, for example, for B. However, what a scenario that this one does not cover is if a group that the student user 1 is a member of, if that group contains some interesting permissions. So if I run this, I would not get anything. But if I run this, we will get many users that we have created in the lab where the student users group has full control, or some control, if not full control. This can also be easily enumerated using Bloodhound, as we saw earlier. The outbound control for the student user 1 showed us where we had permissions. But we can leave this running. The final thing that we are going to discuss on innocent, harmless enumeration is trusts. Now, in any Active Directory environment, trust is a relationship between two domains that allows users and resources from the domains or forests to communicate with each other. A trust can be automatic, like parent-child, same forest, or established, like forest or external. Trusted domain objects represent trust relationships in a domain. So some properties of a trust could be a one-way trust, that is where only users from a particular domain can access the resources of another one, but the other way around would not be true. Please always keep in mind that the direction of access is opposite of the direction of trust. And then there could be two-way trusts, where users and resources from both the domains can access each other. Another property of trusts is trust transitivity. That simply means extension of established trusts with other domains. Please note that all the default intra-forest trust relationships, that is tree root, parent-child, between domains of a same forest are transitive two-way. That is, if domain A and B has a trust relationship, bidirectional trust relationship, and domain B and domain C also has a bidirectional trust relationship, thanks to transitivity, this trust is extended between domain A and C as well. And then there are non-transitive trusts that cannot be extended to other domains in the forest. A non-transitive trust is the default trust between two domains in different forests. And that is called the external trust. All right, and external trust is non-transitive. How are the trusts established? There are default or automatic trusts. Parent-child trust, that is created automatically when a new domain is added to the domain. For example, us.techcop.local is a child of techcop.local. This trust is always two-way transitive. Or a tree root trust, when a new domain tree is added to the forest root. That is also two-way transitive. So as you could see here, all the trust relationships here are two-way transitive trusts. And thanks to that transitivity, if any of the domains in this forest, this is part of the same forest but different trees, if any of the domains in this forest is compromised, an attacker or a threat actor can jump from here to here, assuming that this is the forest root. They can go to forest root and anywhere else as well. In an external trust, what is an external trust? When a trust relationship is established between two separate forests and at least one of the domains is not the forest root. So any trust relationship between the forest roots is called a forest trust. Anything else is called external trust. External trusts can be one-way or two-way, and they are non-transitive. What does the non-transitivity means in this case? Let's say there is a trust relationship between B and Z here, and let's say it is bidirectional. By non-transitivity, it means that the trust relationship between B and Y is not extended to Z. That is what non-transitivity means. Finally, there is forest trust, that is between forest root domains. It cannot be extended to a third forest, that is if forest 1 and 2 has bidirectional trust relationship, and forest 2 and 3 have bidirectional trust relationship. That does not mean that forest 2 and 3 would also have bidirectional trust relationships. However, this can be said to be transitive. What does that mean? If the forest trust is transitive, that would mean that a domain in forest 1 can access resources in another domain in forest 2. Not only the root domains, but the child domains in respective forests as well. All right. Now, why are we spending so much time on trusts? The simple reason being this. This is how many of the domain environments are structured. There would be a forest root. Let's say this is an HQ. Then there would be another location, let's say US. Then TX in US. Let's say then there could be another one in DE, for example. A location in there. Then there could be, let's say, in place of DE or country specific, there could be an EMEA here. There could be an IN, AE, or so on. Now, the problem is that still a lot of organizations do not realize this is still a single forest. What if this is compromised or this is compromised? In any of the cases, the entire forest would be compromised. And by understanding trust relationships, we can also check if this impacts, let's say, a vendor or another forest that may have, let's say, a trust relationship with any of the domains here, or let's say with the forest group itself. Now we can map this sort of attack surface just by running a few commands. Just by running a couple of commands here, we can pretty quickly find out what are the trust relationships in the target environment. So get domain trust gives us a list of all the domains in the current domain. We can run it against the forest root as well. Get AD trust with identity. We can map all the details about the current forest, all the domains in the current forest. We can check global catalogs. We can map trusts for a forest. So running these commands would give us an idea of what the trust relationships look like in the forest environment. So let me show you that in the hands-on 4. We first need to enumerate all domains in the tech-corp.local forest. Let's do that using the AD module. So I'm going to run using the AD module. I will run get AD forest with .domain so that we get all the domains. Just 2 domains in the current forest. The next task is to map the trusts of our current domain us.tech.local. So for that, we can simply run get AD trust with no filter. So we get that our current domain has a parent-child trust relationship with tech.local, of course. And then there is a bidirectional trust relationship with eu.local as well. So let me just by running this command, what we got is this and this as well. All right. The next task is to map external trusts in the tech.local forest. Only the external trusts. So let me run this command. Let me show you the result first, and then I'll explain the command to you. So there is just one external trust in the whole forest. So what are we doing? We are getting all the domains of the forest, and then for each one of them, we are listing trusts that are not within forest, that are not across forest, and also not within forest. So there is just one such trust. All right. If I remove this part, This gives us all the trust relationships in the entire forest. So what do we have here? Of us.taccop.local has not us.taccop.local. Yes. taccop.local has a trust relationship with US vendor.local. So we have this now. taccop.local has a trust relationship that is one way. That was a bidirectional one, the previous one. This is inbound. That is, the trust is from bastion.local to taccop. That is, the access would be other way around, from taccop to bastion. So we know this as well. What else do we know? There is a parent-child trust relationship between US.taccop and taccop. We know that. There is a bidirectional trust relationship between US.taccop and EU.local. We know that as well. Now we can also, the final task, identify external trusts of US domain. Can you enumerate trusts for a trusting forest? Yes. So we can also run this against, let's say, EU.local. I think it is oh, the server, my bad. So if we list trusts of EU.local, we'll see that there is a trust relationship with our current domain, and interestingly, another trust relationship that is with EU vendor. So now we would have this one as well. And not only that, if you have a trust relationship, you get privileges pretty similar, not exactly the same, pretty similar to the authenticated users. What does that mean? That means that we can run stuff like this. That is why I don't type stuff. I copy. See that? We can even enumerate users, ACLs, groups, all the enumeration that we have done up to now for our current domain, we can do that even for EU.local, thanks to the trust relationship. Right. Now let's take a look at some of the enumeration that is a bit more intrusive, not as silent or as harmless as the one that we have been doing. One is user hunting. So we need to simply need to find, let's say, all the machines where our current domain user has local admin access. So we can use find local admin access from PowerView, or we can use find WMI local admin access or find PS remoting local admin access. The idea for all these three commands is pretty much the same. When you run any of these, I mean, the only difference is the way these commands check for local admin access on a machine. So the idea is pretty much this. When you run any of these commands, a request goes to the DC to get a list of all the computers in the domain. And then your machine or process goes to each and every machine in the domain and checks if the current user or the specified user has local admin privileges on any machine. Is this noisy? Yes, because you will leave a log on 4624, a log off 4634 on each machine in the domain, and a 4672 admin logon on any machine where you have success. And if you run it even in a small environment that, let's say, contains 10K nodes, you would cause a network spike, you would cause some network traffic that would be enough for detection. So the ideal way of using this is to use it for against a couple of hundred machines at a time, not more than that. All right, the difference between this is this uses a handle to SCM, this uses WMI, and this one uses partial remoting to check if you have access on the machine. Pretty similar, but more impactful use case is user hunting. That is, if you want to check if there is any machine in the domain where a domain admin has a session, and if your current user has local admin privileges. The idea is, if the domain admin has a session on any machine in the domain, and if you have local admin access there, it would be possible to extract the credentials of the domain admin. A question is, for the previous one, how do you access a couple of hundred machines at a time? All of these scripts support a parameter called computer file. So in place of running them like this, run with dash computer file and specify the list of machines there. Right. Now here, we would like to take this to the next level in terms of privileges. So if you run find domain user location, if you do not specify an identity, it goes for domain admins. So when you run this here, the function requires a list of computers and membership of the domain admins from the domain controller. And then it goes to each and every machine and tries to list sessions and logged on users on machine. If it can list logged on users, then it checks if any of the logged on users is a member of the domain admins, and then it gives you the output. Please keep in mind that for server 2019 onwards, you could not list sessions on remote machines anymore. What does that mean? That means that and what do you need to be able to list currently logged on users? You need local admin privileges. What does that mean? That means that if there is a positive result from any of the machines, that means that you already have local admin privileges there and a domain admin is currently logged on. And then you can simply go ahead and extract the credentials using mimicards or whatsoever you want. All right. That is, check access would not be required anymore. If you would like to run it against only some high value targets, then you can use the stealth parameter. That is, in place of going to all the machines, it goes only to some of the machines where a domain admin may be currently logged on. All right. If you are not using server 2019 machines, you can take a look at NetSeize. I say take a look at NetSeize because it is known to break some stuff. So what we are talking about right now is, if you would like to defend against the domain admin hunting, the user hunting that we discussed just now, you may like to remove the ability. Once again, for server 2019 onwards machine, the ability is already removed to list the sessions. But if you want to do it for, let's say, even the previous machines, you can use the NetSeize script. The NetSeize script removes the permissions of the net session enum Win32 API method from the authenticated users group, and you will get an access denied if you then try to list sessions even on a server 2016 machine. All right. The last thing that we still have 10 more minutes in the session. The last thing that we are going to discuss is privilege escalation. So we have done with the enumeration as of now. Now onwards, whenever we would require enumeration, whenever we need to find out something, we'll do then it as and when required. I mean, no dedicated enumeration after this. So what we have seen up to now in terms of privilege escalation is we can hunt for local admin privileges on other machines. We can hunt for high privilege domain accounts like domain administrator. But before we try them out, let's take a look at local privilege escalation. Why? Having local administrator privileges on your foothold could be very useful to not only persist, but also to escalate, to use tools like variants of mimicards that require you to run from a high integrity process. All right. So let's first take a look at the privilege escalation that can be done, that can be used for on your foothold machine, that is local privilege escalation. First of all, it is missing patches. Things like print nightmare, hive nightmare, or something that shows up. When it comes to security patches, anything that allows you local privilege escalation is usually the least privileged one. So if you are the one who has access to, let's say, exploits or would like to write exploits, you can go for those missing patches. Then there are tools for automated deployment that leave credentials in clear text in files like sysprep.xml or unattend.xml. That is something that we can always check. Auto login passwords in registry. What are auto login passwords? For industries where there is no one to log on to a machine, for example, in medical industry, kiosks, advertisement boards. In such places, there would be no one either technical enough, let's say, even to log on to a machine. That was the idea. Or someone will simply turn on the machine and an application will run. In such scenarios, auto login passwords are used. These are stored in clear in registry and any user can read them. So that can be used for privilege escalation. Of course, always passwords in files in clear text in user documents. There used to be a popular registry entry, which is not so popular anymore. That is always install elevated. In that case, any user can run an MSI as system. Then the last three are the most prevalent ones, I would say. Misconfigured services. So uncoded service path, or where service binary has improper permissions, or the service itself has improper permissions. That comes under misconfigured services. DLL related issues, where you can hijack a DLL or you have the right privileges on a directory. Let's say there is a service that runs a system, but it tries to load a DLL from a directory where you have the right permissions as a non-admin user. So that would help in privilege escalation. And finally, NTLM relay, also known as don't fix. So stuff like juicy potato or remote potato, techniques like that can be used to escalate privileges, and Microsoft does not fix NTLM relaying anymore. All right, they simply tell you to turn off NTLM authentication in your environment, and that's it. So that could also be always useful. Tools like Responder, etc., can be very useful for that. Now we can use PowerUp, BRoot, PrivS, WinPeace, etc. for complete coverage. I mean, if you want, you can, but I do not suggest checking for these opportunities manually. All right. So in the lab, we are going to have only a limited look at local privilege escalation. Actually, we are going to take a look at just 3 methods. Unquoted service path. What is unquoted service path? In case, let's say there is, let me do this. All the services in Windows have a binary path, have a binary. That binary is executed when a service runs. Now, let's say there is a binary that runs something like this. Let's say let's say it is an FTP server that is installed, something like this. See that space here? If this is the path name, the executable path, an attacker can simply go ahead, drop an executable like this, and when the service restarts, it is this executable that will run. This is what unquoted service path is. And if the path was quoted like this, then this vulnerability would not be. Then another issue is the service binary issue. If you can simply go ahead and replace this binary. That is, if you have write permissions here and replace this, drop your own ftp.exe. And the third one is this. Even the services have their security descriptors. So what we are doing, using sc.exe, we are listing sd show, security descriptor show for a service. Now, if a service has misconfigured or overly permissive security descriptor or ACL, like this, then that could be abused. So what is this ACE? This is built-in administrator equivalent permissions for everyone. So these are some of the local privilege escalation opportunities that we can take a look at. We can, of course, use PowerUp or broot or privs or WinPeas to check that. And this brings us to our last hands-on. I actually wanted to complete this today so that we can discuss about lateral movement, but it is fine. The first session is always a bit slower. So in the next session, we'll start with, or let me just complete the first task so that you can get local admin privileges on your machine. Let me do the both of them. I mean, the second one is just a single. Okay, let's do just the first task. Hands-on 5 first task. Exploit a service on student X, that is your student VM, and elevate privileges to local administrator. So we can, in the lab, we are simply using PowerUp. You can try it with WinPeas or whatever the tools that you like the most. I'm using PowerUp just as a filler here. All right. So to escalate privileges, let's load up PowerUp here and run invoke all checks. I think my user might already have. I have to remove the user. All right, and let me log off and log on once. So let me build power up once again. Let's start in Physician to avoid local logging. Load up power up. And now run invoke all checks. A question is, okay, that is answered. Thanks. So we have a service permissions issue here. The ALG service, that is a built-in service, but we have changed it for the sake of the lab. That runs as local system, and our current user can modify it using invoke service abuse. If you take a look at the help of invoke service abuse, we'll see that we can actually add a domain user to the local administrators group if we specify a username parameter. So let's run that now. Invoke service abuse, the name of the abusable service, and the user that we would like to add to the local administrators group. So you could see what happens here. The service is reconfigured. The original path was this, that was changed to this, and then the service is restarted so that the current user or the user specified is added to the local administrator group. Then the original path to the service is restored and the service is restarted. And now my user is a member of the local administrators group. However, to be able to start high integrity processes, right now I would not be able to do that. I need to log off once. And when I log back in, then I would have local admin privileges. All right, the second task is something that we will do in the next session. All right. Any questions on whatever we have discussed up to now? Please keep in mind that the sessions are going to be more intense from 2 onwards. Session 4, second half would be could be a bit relaxed, but session 2 and 3, at least these 2 sessions are going to be very intense. So please come prepared. Please have your coffee ready. And that is all that I'm going to discuss in today's sessions. If there are any questions, please feel free to ask. Any recommendation for a free Windows tool to manage all the sessions in the domain? You can take a look at the terminal. I've not started using it. So you can look at the Windows terminal for that. That could be useful. Right? So I assume that there are no more questions. I'll share the recording as soon as it is available. That should be not more than half an hour. So, yeah, that would be it for today's session. Thanks a lot for joining me, and please practice. Please ask questions, please break stuff, and see you in the next session, and of course on Discord as well. All right. Thanks a lot. Thank you, everyone. And I'll see you later. Bye-bye.